Hi everyone! Alright, so in this video I'll be teaching you guys Cramer's rule. And so let's get started. Let's say I have a matrix being multiplied by a vector x and it equals b, a vector I'll call b. And so what Cramer rule states is that Cramer rule, I can find this x by doing the following. So x would equal a inverse b, where x sub j equals the determinant. Actually, let me put this on the bottom. Okay. X sub j equals determinant of A, where the column j is changed to vector b all over the determinant of the original matrix. And so what this means is that, say I have A, and let's look at the first column of X, which is, I'm going to label it as such, 0, 1, 0, 0, 0, 1. That's going to equal B1, B2. Oh, that's way too close. B1, B2, B3. And then this is A2. Oh, 1, 2. 1, 2. A2, 2. A3, 2. A2. Oh, 3, 1. 3, 1. A. No, that's 1, 3. 1, 3. A. 2, 2, 3. And A, 3, 3. Row. Yeah. Okay. And we'll call this new matrix B1. And so what happened here was that we're looking at X, the column vector of the first column vector of X. And so in the first column of A, we replaced it with B, and the rest of A stayed what it was. And so this is very confusing. So let's run through an example. I think an example will help. Okay. Example. I have a system of equations. 3x1 plus 4x2 equals 2. 5x1 plus 6x2 equals 4. Okay. And so looking at the system of equations, I can write it in this form. So what that will look like is 3, 5, 4, 6 multiplied by x1, x2, and that will equal 2, 4. And so already you can see the form A times vector x equals b, vector b. And so the goal here is to find x, where x vector equals A inverse b. Okay, so let's start off with finding the determinants that we need. So first off, let's do the easy one. We're going to need the determinant of the original matrix A. So that's determinant of A equals determinant of 3, 5, 4, 6. Whoops. which equals -2. Okay. Now, we're going to replace the first column. Ooh. Ah, no. What was that, 3? Yeah. The first column, this first column, with B. So then, we'll have the determinant of B1 equals determinant of, okay, so what's B? B is 2 and 4. I replaced it in the first column, and the rest of the matrix stays the same. What's that determinant? This equals -4. And then, ooh, I'm running out of space. Okay, so the determinant, so A has a second column, so I'm going to replace the second column with the vector B. And I'm going to call that matrix B2. And you'll see in a moment why I'm doing this. So what was the first column of A? It's 3, 5. 3, 5, and I'll replace this second column with, I'm going to write it in a different color, this second column with B. So that's 2 and 4. And that equals 2. Okay, so I'm going to rewrite what we found just so I can stop scrolling back and forth. What? Okay. So the determinant of A was -2. The determinant of B1 was 4. -4. -4. And the determinant of B2 was 2. Okay. So Cramer rule states that x1 equals the determinant of A over the determinant of B1. Right? Because, where is it? Oh gosh. Your first column equals, oh, I flipped it. So sorry. It's B1 over A. Because B1 is that column, is that determinant of the matrix A with the column, the first column replaced with B. So that is, I'm label that x1, minus 4 over 2, -2, just equals 2. And similarly for x2, that's the determinant of B2 all over the determinant of A, which equals 2 over -2, which equals -1. So your x vector ends up being 2 and -1. And you can check it by plugging it in back in, oh god, this equation. So let's do that. I should write smaller. I'm getting tired of scrolling back and forth. Okay, it's 3. What's the term? 3, 5, 4, 6. 5, 4, 6 times x, 2 minus 1. Let's check if it equals b. What was b? 2, 4. Does it equal 2, 4? Let's see. That's 6. Minus 4, that's 2. That's 10. Minus 6, that's 4. And yes, they equal each other. So, if you ever have this equation in this form and you're trying to find this vector x, you could always just implement Cramer's rule. And that's it. Thanks for watching. See y'all next time.